Good day everyone. My name is Alexander Romil Cadeona. I'll be presenting what is mesocompound. Mesocompound Mesocompounds are a chiral compounds that has multiple chiral centers. So ang mesocompound daw kay a chiral compound siya tapos it has a multiple chiral centers. Then a mesocompound or mesoisomer is a non-optically active member of a set of stereoisomers, at least two of which are optically active. This means that despite containing two or more stereogenic centers, the molecule is not chiral. Though na siya ay two or more stereogenic centers, dili gapon siya chiral. A mesocompound is superposable on its mirror image. So, superimposable daw ang mesocompound. Lastly, a compound that has an internal plane. As you can see, this is an internal plane of symmetry. What does what that mean is because the top half of molecule, when reflected across the central line or plane, does in fact give accurately the other half of the molecule. That means this is a plane of symmetry. It is a mesocompound and any mesocompound is a chiral or not chiral. Ang for short, ang mesocompound is a type of a chiral compound then superposable siya on its image. Mo lang to.
Everyone, I am Fabi L. Camposo. I will discuss the diastereomer and the differences between enantiomers and diastereomers. So when we say diastereomers are defined as non-mirror image or non-identical stereoisomers. Hence, they are occur when two or more stereoisomers of compound have different configurations at one or more but not all of the equivalent or related stereocenters and are not mirror image of each other. So when we say stereoisomers, mao ni siya ang duha ka compound na pareha pero dili sila same of configurations or arrangements. So the stereomers are stereomers nga dili related ilang object and mirror image. And also, the stereomers are stereomers that are not are not mirror image of each other and non-superimposable. So, to identify the diastereomers, when we say molecules that are mirror image but not superimposable, ang tawag ana sa iya kay enantiomers. If they are non-superimposable and they dili siya mirror image, ang tawag sa iya diastereomer. So the differences between enantiomers and diastereomers, ang enantiomers mo ni siya ang nag-contain na chiral centers that are superimposable and mirror image that they only come in pairs. While the diastereomers, mao ni siya ang chiral center nga na non-superimposable pero dili siya mirror image. That's all.
Good day everyone. This is my discussion about the enantiomers. So, enantiomers is molecules that have the same connectivity, but if you take the mirror image and rotate one of the compound, they are not overlap precisely and they are not the same in three-dimensional space. So these are also the mirror images of one another and they have different special configuration. This is why how you identify the enantiomers of molecules. So also enantiomers it has this they have the same chemical formula but they're not but they're non-superimposable just like also the astereomers, not super impossible, but the astereomer is non-mirror images, and while the enantiomer is a mirror image of one another. So this is my example. Nothing. So these are enantiomers. These two objects. So this is a mirror. So as you can see, they have the same physical properties, but the mirror image, as you can see, the colored triangle is in the left, and here is the in the right. Then while in the reflection, nag-change ang ilahang position sa lahi ng ilahang ah because nag-reflect man sila sa lahi ng ilahang position. So kung i-overlay na nimo na silang duha, so dili na sila pareha. So mo siya gitawag non super impossible. It's because wala na sila nag-align, or what, not exactly align na sila, dili na sila parehas. So though parehas ang ilahang physical properties, but then kung makita ang color niya, lahi na sila og direction. So these objects are example of enantiomers. So in terms of molecules, so there's how to draw enantiomers, enantiomers in a molecule. So you have to keep everything the same, but change the wedges and dashes, and then put an imaginary mirror and draw everything reflected. So mo ni siya there is a object. So nag-reflect siya, nag-reflect ang molecule, kaning first molecule, may siyang yung reflection, sa nganan siya pag-draw sa enantiomers. So example is the 2-chlorobutane-3-ol. So we have here the mirror, then our 1, 2, 3, 4 carbons, that's butane, and then chloro, since we have chlorine, then nasya sa ikaduha nga carbon, so that's why it's 2-chlorocarbon, 2-chlorobutane-3-ol, 3 because in the OH group is in carbon 3. So the reflection is here, we have 1, 2, 3, and 4. So kay dari kay 1 man diri, so diri pud ato ang 1. 1, 2, 3, 4. So, may reflection ni siya. But then, nag-change ang dashes and wedges. So, there is si chlorine, dashes pa siya. Pag abot na dinhi a wedge, it's because nag-change ang ilahang direction. That's why inganaw na to siya pag-draw og enantiomer. So, i-change lang na to ang mga wedges and dashes niya. So, another is the 2-chlorobutane-3-ol gihapon. So kwaon na to ang iyang chirality. So this sa carbon. So chirality ani niya na diri So having 4 groups. So nani siya hydrogen diri ang apart. So manini siya gidrawing na nato siya na nay hydrogen dira gid nato siya i-dash. So another way to draw the enantiomers is to put an imaginary mirror and draw everything reflected. So that is how we draw the 2-chlorobutane-3-ol of enantiomers of 2-chlorobutane-3-ol. So it's just we draw the reflection kung saan yung reflection. So dari siya na siya sa right, dari na po siya sa left. Kaya syempre mo na siya ang dual sa mirror na nag-reflect lang na sila. So that's it. That's how we identify the enantiomers of molecules. So furthermore, natay mga examples, other examples on how to draw the the enantiomers of the molecules, also the astromers and the meso compounds. So that's all. Thank you.
Okay, good day everyone. So by the way, I'm Angeline Diorsen. I'm tasked to discuss about the examples of mesocompound. Okay, before that, what is a mesocompound? Mesocompounds are chiral compounds that has multiple chiral centers. It is superimposed on its mirror image and it is optically inactive despite its stereocenters. Okay, let's proceed to the examples. So this one, what do you think of this molecule? Is it a meso compound? Okay. So this line here is stands for internal symmetry, and it's a line that splits into two parts, right? The OH and the H are not the same, so therefore there's no line symmetry, meaning that the molecule as a whole is a chiral and it has two chiral centers. So therefore we are going to draw a mirror image of these molecules. And it's going to be unnatural. So enantiomers are chiral molecules and they have more centers. They have more chiral centers. The mesocompounds are chiral molecules, but they still have chiral centers, right? Chiral sila, pero nagyan po sila multiple chiral centers. Diba? So, thus two unaddressed that they don't have an internal line of symmetry, but they are, what do you think of them? They are, mesocompound, they are optically active and a chiral. Okay, the next sample. Okay, let's proceed to the next sample. This one. So this one is like, example is like, which of the following molecules are optically active and which one are optically inactive? So we're going to define kung optically active siya or optically inactive siya. Diba? Pag mesocompound siya, so optically inactive siya, chiral siya, and pag dili, optically active siya o chiral siya. Kaya naman pag meso ka is a chiral man. Okay. So this example is a mesocompound. Why mesocompound? It is because inactive siya and a chiral siya. This one. Right, diba? They are the same and the same. Okay. Okay, let's proceed to the next sample. This one. What do you think of this? Is this a chiral? What do you think of this? Is this molecule is a chiral centers or not? So what do you think of this molecule? Well, actually, this molecule is optically active because there is line of symmetry. So not a mesocompound. If it is optically inactive, therefore, chiral siya. Okay? Diba? Isa lang ang H niya, diba? OH rather. Okay, the next example. This one. What do you think of this molecule? Well, actually, the OH and the OH are the same. And it is example of a mesocompound also. Kasi optically inactive man siya. And chiral siya, diba? So, the next example. So, what do you think of this next example? Well, I forgot to put a line that splits into together. Okay, this example is not a mesocompound. Why? It is because this H and HJ, this H and this H are the same, right? The OH and the OH are the same, but why is it not a mesocompound? It is because si methyl group o si ethyl group are not the same. So that's why not mesocompound sila and optically active sila and they are chiral. Thank you. That's all.
This is the example of diastereomers. stereoisomers that are not mirror images. So compounds are known as the stereoisomers, like they have the same exact molecular formula, but different arrangements of atoms. So enantiomers are compounds that have the same exact molecular formula, but they have mirror images here, enantiomers, of one another. So they are called the one-type stereoisomers. So in this lecture, we will talk about a second type of stereoisomers that is known as diastereomers. So when they have the same molecular formula but different arrangement of atoms, so for example, we spoke about enantiomers. So let us begin by looking the following pair of enantiomers. So this is the enantiomers, and here we have the mirror images of these enantiomers called the isenantiomers. So we have here the 4 different groups attached to each enantiomers. So we also have a second pair of enantiomers, a different pair. We have here the R enantiomers and S enantiomers. Now, these two pairs are exactly the same. These compounds are identical. NR and S and S. So let's suppose we have a reaction. A reaction takes place between these R enantiomers and these two R and S enantiomers. And we have to know to bond this form between this carbon and this stereogenic carbon. Now, first, the reaction between R and R that will produce the R and R compounds. So we will call it a compound. Next, the R reacts to the S and it will produce the R and S compounds. So let's call it B compounds. Same exact things happens with the S enantiomers, or the mirror of these images are enantiomers. So S reacts to the R and it will produce the S and R compounds. So that is a C compounds, and S reacts to the S and it will become S and S compounds. So that is the D compound. Because if we look compound A, so what's the mirror images of R and R? Absolute configuration. But whenever we take the images, we switch from R to S to R. So so the mirror of RR, or A compound is D compound. RR, the mirror of it is the SS, or D compound. So this we call A and D, this we call the enantiomers because they are the mirror images of it. And next, the R and S and S and R. So B and C, look at this, they are the mirror. So these two are the enantiomers too. Unlike for compound A and B, R and R, R and S, so A and B compound, they are diastereomers because they are identical. And same as here for the C compound and D compounds, S to R and SS, they are called diastereomers. Now, look what we did. We essentially took R to combine them with R and S. Same here from S, R, and S. In other words, what we did is we combined the two enantiomers, to produce different stereoisomers. So whenever it's stereogenic carbons, to find the total of the maximum number of stereoisomers, we use the following formula. Here it is, the formula: 2 to the power of n, because we have here two different carbons, so that our n here is 2. So 2 and 2 becomes 4. So 4. So we have here 4 different compounds: the A compound, B compound, C compound, and D compound. So that is a total of stereoisomers we used. So that's it.
So now I'm gonna show more examples about how to identify enantiomers of the molecules. So another way to know if the molecules are enantiomers, if they have different special configurations, or the molecules in the enantiomers are non-superimposable, so they have different special configurations. So in my first example, I have the 2-chlorobutantriol. So it's 2. So let's get the configuration. So the configurations are the RS configurations, or the RS system. So here, in knowing the RS configuration, so we have to number the elements present in these molecules by their atomic number. Chlorine here will be the one because it has the highest atomic number. Next is the OH group, and then the methyl group. Hydrogen is the least because it has 1 atomic number, so it's 4. So this numbering we will create a arrow to know if what is the configuration in this molecule. So since it's here 1, 2, 3, 4, so let's make the arrow. So this is how we know the configuration of the molecule. So remember that the enantiomer has different special configuration. So if these two have different special configuration, then we can conclude that these are enantiomers. How about this one? So it's the rotation. So the rotation here in first is counterclockwise. So we have our S. So S is for meaning Greek word sinister. So let's number this one also. We have this 1, 2, and 3, and 4. So the rotation will goes like this, and it's clockwise. So let's have the R. So in naming this molecule, so we have S, 2-chlorobutantriol, and this is R, 2-chlorobutantriol. So if we draw the first structure given, so it's that's it. So now here I have exercises on how to draw enantiomers. So the first one is we have to do the reverse, or to do the mirror, and reverse the atoms of the molecules. So we have here our, what's the mirror? Then we have this CH2, CH3. Then we have to reverse this hydrogen and fluorine. So hydrogen now will be in the mirror, then the fluorine will be here, then the CH3. So it's reversed using the mirror. Then number 2, same way, we have the CH3. Now the fluorine will be here and hydrogen will be here, and bromine will be in the right, and the hydrogen will be now on the left. So how about here in number 3? Here let's just change the wedges, so it's a wedge line to dashes to give its enantiomer, since mag-change man ang ilahang direction. So it will become, so mali dito kung example kaganiha nga nagbutang ko og mirror, so it will become Cl. So it's not like this. Same structure, but the same structure, same physical properties, but then the wedges and the dashes changes. So from wedge line to dashes. So how about this one? We have wedges and dashes in the first image. So let's just have to change it. Now the chlorine will have the dashes, and the bromine will now have the wedge line. So that's how you write the enantiomers of the molecules. The next one is we have here. So let's just have use the mirror, imaginary mirror, to draw this one. So sorry. Then we have our wedge line here, fluorine, and our wedges. Here, using the first way, let's just change the wedge and the dashes. So in number 5 we use the mirror, and now let's just change the dashes and wedges. So same, so dire siya mabutang, but then it will change into dashes. So we have fluorine, and this one will now have a wedge line. So yeah, that's it. That's how you draw the enantiomers of the molecule. So we have to remember that enantiomers always come always in pairs, and they are the mirror images of one another, but then they are not non-superimposable because they have differences. Same way in a three-dimensional space, if you rotate the molecules, so dili na sila so na changes sa ilaha. So that is enantiomer. So in summary also, we have to know that enantiomers are molecules in which all the stereogenic centers, or the chiral centers, so just like this one, our chiral centers are in the opposite configuration. So that's why I use the RNS system. So if i-rotate na to sila niya, same lang gihapon ang ilahang mga naong, ang ilaha walay changes na itabo sa ilaha. So wato siya lagi gitawag og mesocompounds. That's all. Thank you.